Hello, friends. How are you? I hope all of you are doing good and keeping very well. Today, actually, we will be doing a JEE Advanced question on complex numbers. This actually came in the 2013 paper 1. So, this is a single option correct type question. So, let's see how to proceed and how to approach this question in the best way. So, first of all, friends, sometimes just on upon seeing the question we might be a little bit reluctant on attempting it, but you just don't have to feel hesitant just by seeing the length or the size of the problem statement. Basically, if you read the question like 2 3 or 4 times, it just starts to form an image in your mind and things start to get clearer. So let's focus here. First of all, one thing that we must know about the G Advanced exam is that uh, they don't actually want you to hit repeatedly at a point. They just want you to hit at the right point. So, if you know the correct approach, it must all boil down to some simple things. Okay, so let's see. Uh, First thing that we should notice here is that two circles basically are given here. So, if we try to solve this question by using the coordinate system approach, things could get pretty messy because two circles involved, then modulus is involved. So that would not be the correct approach. So basically, we should stick to the complex number form and use identities of modulus and conjugate to tackle the problem. So let's see. First of all, we will write both the equations of the circle in the complex form. We will use complex geometry to solve this. So one equation is the other one is this. So and we are given that uh, this we are given, okay? So we will write the first equation like this reduces it to complex form, and the second like z minus. Okay, so that is done. Now we are given that uh, alpha. Okay, so alpha lies on this circle. Alpha lies on this circle, and 1 over alpha and 1 over alpha bar lies on this circle. Okay, fair enough. So let's form the special case like by putting alpha. That's equation 1. That makes sense. And we have another equation, this one that is relating z naught n. This is given. Okay, so now what we will do is we will be squaring equations 1 and 2. Fair enough. So now we will use the property of modulus and conjugates. Okay, and write it like this. And the second equation will be, I just have used that the fact that, okay, this I have used. So now our two equations become, okay. So proceeding now, now we have reached a good position. We have z, this term here, couple of r's. So and these terms. Okay, so a lot of possibilities are there for cancellation and elimination. So upon further simplifying um, the first equation, okay, this can be written as, okay, in fact we can, you know, this also we can write it like. And now the similarly with the second equation, let me make it more clear. Okay, similarly with the second equation, we can write it like this. This can be in fact further solved. This one only, this is done. Okay, this is pretty much done. And this we can write like, by taking the denominator, taking the LCM. Okay, I've just taken the LCM and made a common denominator. So now this again we can write as this. Okay, so I will take this common and we will be left with, okay, so that sounds good. And then our other equation was, so the things that we absolutely don't need are these and these, because they are also they are complex quantities both, and we just don't really need them. So they are present in both the equations. That is a very good thing for us because they can be easily eliminated. Okay, so now we will use our third and most important equation that was already given in the question, this question. Okay, this Z01. Let's simplify this. Okay, now we will use this value of z0, and we are going to use it in these equations. So what do we get? So this will be simplified to, basically you can see that this term here will be simplified to 2r square minus r square. So r square minus 2 over 2. Okay, 2r square minus r square minus, okay, and this will be simplified to 8r square minus r square, 7r square and minus 2 over 2. Okay, so we will write that down. Okay, now the only last step is left, that is to get rid of this. So let's find out the value of this term from this equation. So what we get is okay, now we will be using this in here. So finally we get one. A minus sign is here also, and we have taken the value of minus sign here also. So the net effect will be plus here, and okay, instead of writing this modulus of alpha repeatedly, just to simplify our work, okay, let's make a change of variables. So let's now multiply it by 2 throughout. Okay, again cross multiplying, clearly x will not be equal to 0 because neither of these circle is actually passing through the origin. Okay, so x is not equal to 0, so we can cross multiply by x squared. Okay, that's good. So this can cancel. Okay, take the 2x square on the other side, and now we are finally getting close to our answer. So guys, here we are. Now r square can get cancelled from both of the sides, so x square is actually 1 by 7. So we have finally reached. So this implies that x will be actually plus minus 1 by square root of 7. Okay, so modulus of alpha is equal to plus minus 1 by square root of 7, but careful, this can also come into a multiple choice, multiple option correct. So what we must know that this modulus of alpha is always greater than equal to 0. Okay, because this is a kind of absolute value. Okay, so only we take only the positive value as the answer. So finally this will be our answer, friends. Let's see if, yeah, so option C will be the answer. So thank you guys for watching the video. I really hope that you would have loved it and liked the question. uh, if you have any better approach or more efficient way of solving this problem, please kindly put it in the comment box so that other people can also know, or mail it to me on my email ID. Thank you guys. Please like, share and subscribe, and most importantly share it with your friends. Thank you guys.